Okay, today we're looking at target class B. We're going to be talking about wave frequency. So our mastery objective is I can calculate simple and compound probability by interpreting two-way frequency. So the two-way frequency table is this new our vocabulary we're going to be looking at, the new type of things we're going to be looking at. But everything else is still just probability. So, two-way frequency table. The two-way frequency table is a representation of the data from two different categories. For example, right here, it's either I have been to Mexico, not been to Mexico, have been to Canada, have not been to Canada. Those are, Mexico and Canada are my two different categories. We're also going to be looking at conditional probability, which is the probability of an event. Okay, the first event is A, given that another event has already occurred. Okay, so we will call it conditional probability. I will also often refer to it as a given probability. That's your key word. Just like independent events, the key word is and exclusive, your key word is or. Alright, so looking at example 1, we're going to be using this table for this whole page, so I'll keep kind of scrolling up and down. Example 1, a class was surveyed about whether they have been to Canada or Mexico. Use the table on the right to answer the following questions. Alright, there's two types of questions you're going to see. There's going to be how many, questions that say how many, and questions that say probability. How many is just a number. There's questions that say how many and questions that say probability. So when you have a question that says how many, right, so this is how many, you're just looking for a number. It's not a fraction, it's not a probability, it's just a number. So how many students have been to Mexico? Well, I'm just looking at this one. This is have been to Mexico and they've been to Canada. This is have been to Mexico and have not been to Canada. Well, I don't care. This question is not asking me anything about Canada, right? So I just want to know the total number of students that have been to Mexico. Alright, so the answer is 9 students have been to Mexico. B, how many students have been to Mexico and have not been to Canada? So again, this is a how many question, so that's just looking for a number. How many students have been to Mexico and, so I'm going to be looking at two different categories here. Again, we're just reading the table though. They have been to Mexico, have not been to Canada. So I'm looking for these two lines where they meet. There's 3 students that fit under both those arrows. So you're kind of looking at where those students meet. So 3 students have been to Mexico and have not been to Canada. Okay, what is the probability of a student having been to Canada? Okay. So now I'm looking at probability. Probability is, when it asks for probability, you are looking for a fraction. So I need to know, right, how many students have been to Canada over how many total students. Okay. How many students have been to Canada? There's 11 Canada students. So 11 have been to Canada. Over how many total? Well, my total is 25. So over 25 total students were asked in this survey. So my probability is 11 over 25. As you're writing your answer, you can just put 11 over 25. I just like writing this down to let you know where it comes from. So 11 from Canada over 25 total. Our next question, what is the probability of having been to Mexico and Canada? So again, I'm going to look at having been to Mexico and having been to Canada. What number is this? Well, there's 6 that have been to both. And then still the total of how many people is 25 over 25 total. That's 6 over 25. That also cannot be reduced. That's my probability is 6 have been to both Mexico and Canada over 25 total. Alright, and then finally E. What is the probability of a student having been to Mexico given that they have not been to Canada? So, this word given is important. I'm going to circle what comes after the given. I already know that they have not been to Canada. So we only look at no Canada. So what do I mean by that? When I'm up at my table, right, I'm going to circle or put a box around having not been to Canada. Right? So put a box around having not been to Canada. Looking at that box, now I'm going to find the probability of a student that has been to Mexico. So I'm still looking at going to Mexico. There are 3 Mexico students over how many total students? Well, my total students have changed 2. I'm only looking in this box. My total is there are only 14 total students who have been to Canada. So it's actually 3 over 14. So those givens are a little weird. So it's 3 over 14 when you have that given. All right, let's look at just a few more examples on the next page. Alright, so using this table, find the following probabilities. So, we are finding probabilities. One thing to note is this line means given. So this is the same thing as just having that word given here. A grade 8th grade girl, or sorry, in 8th grade, given they're a girl. Okay? So, we're doing the same type of thing. I am going to circle what comes after the girl, or what comes after the given. Let's see. I'm going to circle what comes after given, because that's what I'm going to circle on my chart. Okay. So I'm only looking at girls on my chart. I can completely ignore the other 2 columns. I'm not going to use any numbers from there. So what is the probability they're in 8th grade? Well, looking under 8th grade, there's 12 8th grade out of 27 total. So that's 12 out of 27. Easy enough. Be careful, because it does matter which one you look at. Now I'm going to look at kind of like the opposite here. The probability of a girl given they're in 8th grade. Well, now what am I circling? I'm circling what's after that given. So I'm circling 8th grade. So I'm going to draw my box around here. So finding the probability of a girl, there's 12 girls out of, now my total is 22. 12 out of 22 does reduce to 6 out of 11. Okay? So these are very different answers. So it does matter what the order is. Be very careful with that. Alright, looking at our next one. Alright, same kind of thing, probably a boy given they're in 7th grade, or probably a 7th grade given they're a boy. So, probably a boy given they're in 7th grade, certainly what comes after the given. So I'm going to put a box around 7th grade. So for this problem, I'm only looking inside that green box. The probability of a boy is there's 6 boys. Over 13 total, which is just 6 over 13. So that's one, right? I'm going to circle comes after the given. I'm going to circle boys. Probably in 7th grade, there's 6 in 7th grade. Over, right now there's 23 total, which doesn't reduce, so it's just 6 over 23. Okay. So those given probabilities are a little strange. All right, that is it. Go ahead and work on 5B.1.